Today, in this lecture, we are considering about the expression for the thermodynamic change. That change is isothermal. Okay. So, what we are going to derive in this is to understand once again the isothermal change and the work done during isothermal change. So friends, you know the different types of the processes. There are at least 5 processes. One is isothermal, another is adiabatic, third one is isobaric, isochoric, and one more is that is nothing but quasi-static process. So all of you know that during the isothermal process, what quantity is constant? Temperature T is constant. Temperature T is constant. That means dT is 0. Change in temperature is 0. So we can define first of all the isothermal process. So isothermal process is the process of change in thermodynamic state. Change in thermodynamic state at constant temperature. That is called as isothermal change. So for that, we have to consider first of all the simplest model, that is the gas filled in a cylinder with piston, frictionless piston. This is a frictionless piston. Suppose this pressure is P1, volume is V1, and temperature is T. As the temperature is constant, if you change the state, change करना म्हणजे काय करणार आहे तुम्ही? सिस्टीम हीच राहणार आहे, पण त्याचे जे व्हेरिएबल्स आहेत P1, V1, एंट्रॉपी, हे आपण चेंज करणार. याचा अर्थ you have to change the parameters of the state. Already you know that there are 3 different ways to change the parameters of the state. So consider this is a state A. If any one parameter changes, then this state can be changed into another state. Now in this process, isothermal process, we are not changing the temperature. When not changing the temperature, that means whatever the change in internal energy must go out when we are compressing or providing certain energy. Or in reverse case, if we are expanding the gas, then this same amount of energy is coming outside to that system, so that once again temperature remains constant. हे तुम्हाला समजलं का? आपण काय करणार आहे की आयसोथर्मल चेंज करणार आहे. सपोज करूया की आपण A is a thermodynamic state having these parameters or thermodynamic variables P1, V1, T. And this state now we are going to change to B, P2, V2 and T. So T is a constant. आता स्लोली आपण काय करूया, पिस्टन थोडंसं स्लोली वर घेऊया. वर घेतलं तर काय होईल, the volume changes V1 to V2. So piston is moving upside, that means we are reducing the pressure. That means pressure P1 is greater than P2. So P1 changes to P2. when the gas is expanding, the volume is increasing, then it becomes cooler. Gas becomes cooler. But at the same time, as we know that this boundary is a dithermic boundary, then same amount of energy comes inside from the surrounding, so that again it becomes thermal equilibrium with respect to surrounding. That means there is no change in temperature. So if no change in temperature, then its internal energy also doesn't change. So that means du must be equal to 0. So according to first law of thermodynamics, dq is equal to du plus dw. So already we know that dq is equal to du is 0. 0 means dw, or you may say that dq must be equal to dw. So during the isothermal change, whatever the work is done on the system or by the system, that has directly converted into heat. There will be no change in its internal energy. So keeping all this in mind, now we are going to calculate the work done during the isothermal change. To calculate the work done, first of all, suppose the area of this cross-sectional area of this cylinder is, suppose that is A, and gas, whenever it is expanding, then piston moves certain distance, small distance, let's say dx. Piston is moving outside, or may be considered inside, whatever it may be. So it is moving outside, let us consider outside. Then dx is a displacement, A is a area, and pressure is P. Then the work done, small work done, moving the piston for small displacement, it is represented as dw, that is given by force into displacement. You know the definition of work done. Work done is nothing but force into displacement. So dw is equal to, here what is force? Force is nothing but pressure exerted by the gas per unit area. So that means force is pressure into area is nothing but force. So force divided by area is nothing but pressure. So force you can write P into A into, that is displacement, is dx. हे समजलं तुम्हाला की वर्क डन म्हणजे फोर्स इनटू डिस्प्लेसमेंट. वर्क डन आपण स्मॉल कॅल्क्युलेट केले कारण स्मॉल डिस्प्लेसमेंट आहे. dw इज इक्वल टू फोर्स म्हणजे काय, प्रेशर इनटू एरिया, आणि डिस्प्लेसमेंट किती आपण मानलं dx. सो dw that must be equal to P into A into dx. हे सिलेंडर सारखं ऍक्ट होईल, हा एरिया A into dx, that is change in, small change in its volume. So dw is equal to P into dv. Equation number 1. To calculate the maximum, that is from V1 to V2, change in volume, you have to calculate the work done, total work done. So this work done is very small work done. To calculate from V1 to V2, we have to integrate this equation. So when you integrate this equation, you will get dw 0 to w, that is the work done, total work done, that is equal to P integration of V1 to V2, P into dv. So integration and differentiation gets cancelled, you know that all. So integration differentiation gets cancelled, remains, that is w, that must be equal to, here the integration right once again, V1 to V2, P into dv. Equation number 2. Already we know this gas, suppose this gas is an ideal gas and the number of mole is 1. one number of mole of gas is filled in a cylinder. Then for ideal gas, you know the relation PV is equal to nRT. Or we can write for one mole of gas PV is equal to RT. So you know that R is a gas constant, and in isothermal process this T is also constant. That means PV is equal to this total term becomes constant. So PV is equal to constant. Listen, PV is equal to constant quantity, or you may say RT is a constant quantity. So P is equal to किंवा याचा आपण जर डिफरन्शिएशन घेतला तर 0 होईल, पण P ची व्हॅल्यू आपण सबस्टिट्यूट करूया. P is equal to RT divided by P. So from this equation we can get the value of pressure, that is RT divided by P. So put this value in this equation P instead of P. So this equation becomes W is equal to integration P1 to V2 instead of P you have to substitute RT divided by V into D. So once again W is equal to, so as we know that R is constant, T is, in this case T is constant, so both constants taken outside the integration. So RT integration of P1 to V2 dV divided by P. Now W is equal to RT is a constant. So any integration, there is one mathematical formula. You, I think, know that integration of anything, integration of 1 divided by x into dx is log of x. Log of x. So put that value in this equation, you will get the integration log of to the base e, log of v from integration limits v1 to v2. So what we have substituted, that integration of dv divided by v is nothing but log of v to the base e, v1 to v2 integration limits. So putting the integration limits, we will write that RT is equal to, so log of, instead of v you have to put v2 to the base e minus log of, instead of v, v1 log of to the base e. There is one more mathematical formula, that log a minus log b, that gives log a divided by b. Log a divided by b. That means log of a plus log of b, that is equal to log a divided by b. W is equal to RT, keep constant, RT is keep constant. Then log a minus log b, that means here it is minus sign. So log a minus log b means log a divided by b, log of p2 divided by p1 to the base. So we get the work done is equal to in this equation. To remove the log of to the base e to the log base a, what you are going to multiply? You are going to multiply that 2.303 into RT log of V2 divided by V1 to the base 10. So this is the expression for work done during the isothermal change. म्हणजे काय की आयसोथर्मल चेंज उदाहरण आपण बघूया. समजा तुमच्या समोर आईस आहे, त्या प्लेटवर तुम्ही आईस घेतला आणि त्या आईसला स्लोली यू आर प्रोव्हाइडिंग हीट. आयदर यू आर डूइंग वर्क or you are providing the heat. There will be change in its state. So that means that ice is now converting into water. When ice is converting into the water, there is no change in its temperature, no doubt. When ice converts at particular temperature in water, then there will be no change in its temperature. That means that process is called as isothermal process. But its volume of ice and volume of water is different. So that means we are providing that V1 and V2 are different, particular temperature, you know that. Then how much amount of work done? Work done means it requires the amount of energy to convert ice into water. That is given by this one. Similarly, another example you may consider that when water boils, water is converting into vapor at particular temperature, let's say 100 degrees centigrade. Then at that temperature, there will be no change in its temperature. No change in its temperature. Water, it is in the form of liquid, highly boiled water. It is in the form of liquid. But when it is going in the vapor state, that means one state is changed to another state. There will be no change in its temperature. So that means here the temperature remains constant. That also the process is called as the isothermal process. So two examples you may consider as an isothermal process, where one process is the conversion of ice into water at constant temperature. This is isothermal process. Another, that is the conversion of water into vapor. That is also the isothermal change. So how much amount of heat required at that point, heat or how much amount of energy required at that point is nothing but work done. Work done is also one type of energy. Heat is also one type of energy. Internal energy is also one type of energy. Already we know that all these things. So that means W is the amount of energy required to convert one state into another state at constant temperature is given by this relation. If in some times you don't know the volume, then you may convert that relation in terms of pressure. So already we know the relation, that is PV is equal to nRT, or PV is equal to, you may say, for 1 mole cup gas, that is PV is equal to RT. So this equation once again we can use that PV is equal to RT. Similarly, P1, V1 is equal to RT because RT is constant. P2, V2 is also RT. So this gives rise to what relation? P1 is equal to RT divided by P1. This relation gives P2 is equal to RT divided by P2. Is it? So now when you divide V2 divided by V1, you will get V2 divided by V1. That will get, first of all, keep the value of V2. So the RT divided by P2 into, that is reverse multiplication, P1 divided by RT. So RT gets cancelled. And you will get the P1 divided by P2 instead of P2 divided by V1. So this work done value can be changed into another value, another form, that is W is equal to 2.303 RT log of 2 to the base 10 P1 divided by P2. This is for 1 mole of gas. If there are n mole of gas, you can multiply by n, that is W is equal to 2.303 nRT log of P1 divided by P2 to the base 10. So this is the amount of energy required to change the state A to state B. So work done is once again one type of energy. That amount of energy required to change the state A of this one system to the state of another state of the same system. Is it? Another state of the same system. Now you can represent this change in the indicator diagram. Already we know what is nothing but indicator diagram. Indicator diagram is the relation between the state variables. The indicator diagram may be P and V, P and T, V and T, P and entropy, etc. So now, for the sake of simplicity, we are going to consider the relation between the two states with pressure and volume. Suppose at particular state P1, you suppose P1 and this is the V1. P1. This state you consider as a P1, V1 and T. T is always constant. So this is the state of that system what we are supposed to, that is the cylinder. When that state changes from A state to another state, that is state B, at constant temperature, then this we will get obtained the T, that is P2, V2, temperature remains constant. So isothermal curve you will obtain. So this value, that is value V2, this value is P2, and the area under this curve, in the area under this curve, gives the value of this work done. So work done is nothing but amount of energy required. The area under this curve will give also the amount of energy required to convert the state A to state B. This is known as the indicator diagram. If you know all that is the points between A and B, then you can draw the diagram very easily. For that, the condition is to change the state from A to B is very slow, not very fast, is it? So when you change the state very slowly, that means you are going to expand the gas very slowly. When gas expands, its temperature goes down, but same amount of temperature comes out from the surrounding. That means again temperature remains constant. Again you are going to expand the gas. Again temperature comes, heat comes from the outside, temperature remains constant. So slowly if you go, then this is known as the isothermal change. So isothermal change is very slow and that is the steady process. Each and every step is known, then this is called as the thermodynamic process and isothermal thermodynamic process from A to B, and this is the expression for the amount of energy required to change the state from A to B. Okay, this is all about the isothermal change. Thank you.